In this lecture, we're going to learn about some functors we have built into the C++ standard library. And here we have a few examples. For example, we have a functor to add stuff up. So std plus, you can specify whatever you want to add. And I mean the type here. So you can add up strings, you can add up integers, you can add up double types. You can really do all kinds of crazy things. We have another functor, for example, to subtract things. We have another functor to compare stuff, and all of these are built into the C++ standard library. You don't have to go through the trouble to set them up yourself. Down here, you see that we are using our adder functor to add 10 and 7. And if we try to print this out, we will get a 17 printed out. We have one to subtract here, and it is going to subtract 7 from 10, and this is going to give us a 3. And we have another one which is going to compare two things. So it is going to tell us if 10 is greater than 7. If 10 is greater, we're going to get a true out of this. If 10 is not less than 7, we will get a false out of this. And everything here is going to work. These are just a few functors I have chosen to show you as an example. But for a full list of those, I would refer you to your favorite C++ standard reference. Mine happens to be cppreference.com. So if we go here, for example, and scroll down, we're going to find all these functors here. We have plus, we have minus, we have multiplies, we have divides, we have one for modulus. We can really use all these things if they make sense for the application we are trying to build. For example, if we double click on the plus functor here, we will see that it can be used to effectively act as operator plus on two instances of type T. So it is basically going to add two things up. If we go down here, we're going to find a possible implementation. So it is really like an operator that adds up two parameters that you give to it. We're going to take something on the left and something on the right. We're going to add them up, and then we're going to return the data to be used by whoever happened to call this function here. This is how these guys are going to work. If you go back here, you can find all the others. For example, we can expand on this greater one here, and it is going to be used to compare things. You're going to see that it is templated, so we can use this to compare anything really. And the compiler is going to generate a template instance that does what we want. If we go down here, I think we're going to find a bunch of examples, but we don't. So this is a possible implementation of this. Again, it is going to compare the left operand to the right operand. If what you have on the left is greater, you're going to get a true out of this. If what you have on the right is greater, you're going to get a false out of this. This is how this functor can work in your C++ program. If you want, you can really explore all these if you need them in your C++ program. But for now, we're going to come back to our slides and see how we can apply these things to compare stuff in our box container class, because that's going to be really cool. So what we're going to do, we're going to template on the comparator type that we pass in here. And this is going to give us the flexibility to do all kinds of crazy things. For example, we can use functors as callbacks. And these are going to be custom functors that we build ourselves. We can use standard functors that we have just learned about. Or we can even use raw, plain old function pointers. So we have this flexibility here because we are templating on the comparator type that we pass here. We also need another template parameter for the type that is contained in our box container, and this is how we do this. So we're going to do what we have been doing all along. We're going to loop around trying to find the best item. If we find it, we're going to store it in our best variable here. And by the time the loop here is done, the best item will be in this variable, and we will return it to be used by whoever happened to call this function here. And the compiler is going to generate whatever template instance we need for what we use in our main function. So for this to work, for example, we can set up a bunch of callbacks. We can set up a callback in the form of a regular function. This one is a simple function. We have custom grader, so it is going to take two parameters. We are going to compare them, and if what we have on the left is greater, we're going to return a true, and we're going to return a false otherwise. Down here, you see that we can set up a functor, and this is a custom functor that we build ourselves. So we can use this as a callback. Again, this is going to do the comparison. So it is going to compare whatever we have on the left to what we have to the right. If what we have on the left is greater, we're going to return a true. if what we have to the right is greater, we're going to return a false. This is the setup we have here. But we can also use standard functors. So if we go down here in this slide, we're going to see that we can use std greater and specify that this is going to be comparing strings, and we will use this string comparator to compare two strings. And if what we have on the left is greater, the comparator is going to return a true. If what we have to the right is greater, we're going to return a false. This is how this is going to work. So we can really use any of these three function-like entities as callbacks. In the first call here, we are going to use a built-in functor, which is our string comparator. In the second call here, we will be using our regular function pointer. So this is going to be instantiated for std string. Remember that custom greater was a function template, but we can also use a custom functor, so we can set that up here, for example, to compare two strings, and we're going to use that as a comparator in our getBest function, and it is going to work. So seeing what we have seen, it is really possible to pass anything as a comparator in our function here. The only requirement is that we should be able to compare two things with this comparator, and all we need is really the less than operator that we can use to compare things and get the best thing out of our box container of objects. So for example, we can also set up a box container for ints and really compare things. We can add stuff here. We can use a built-in standard functor as we see here. This is int comparator. We can use that right here. We can use our own customly built functor to compare things. So this is going to be greater int custom functor. We can use that right here. We can even instantiate our custom greater function, and it is going to work as a callback for our function here, and everything is going to fall in place. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Standard Functors. We are going to grab our template files and put them in place. Let's copy those. I am going to put in my box container class. If you want the code, you can grab this from the resource section of this lecture. And I am going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us our thing. We will have our main CPP file, so we can clean it up a little bit. And one thing I haven't mentioned is that all these standard functors live in the functional header as you see right here. So we will need to include this if we need access to them. That's what we're going to do in Visual Studio Code. So we're going to include this little guy here. We're going to include functional. And we will go in our main function and set up a few of these standard functors. We're going to set up one to add stuff up. We're going to set up one to subtract. And we're going to set up another one to compare integers. And we're going to specify which type these functors work on as a template argument. This is really important because most of these guys are really templated to make them flexible to work with. So we're going to have int as our template argument here. And all these guys are going to be working on integers. So the first one is going to add up 10 and 7, and this is going to give us 17. This is not hard to see now. We're going to do 10 minus 7, and this is going to give us a 3. And we are going to compare and see if 10 is greater than 7, and this is going to be a true because obviously 10 is greater than 7. So we expect to get a true out of this. And if we build and run this program, let's see what we get. We can pass this through our GCC compiler. The build is going to be good, so we can bring up our terminal window, and we're going to say clear and run rooster. We're going to see that 10 plus 7, that's 17. 10 minus 7, that's going to be a 3. And 10 greater than 7, this is going to be a true. You see that these guys are really working. Okay, now that we know how to basically work with these standard functors, we're going to set up a function which is going to be our getBest function we know and love at this moment. And it is going to be trying to get the best item from a box container of items. For this, we need to include box container, so let's do that. And it is available in our project. We have brought this in. So what this function is going to do, it is going to use whatever callback we pass here and use that to compare and see if one item is better than another. And what defines best is the comparator that we're going to pass here as a callback. Because we are templating on our comparator here, we can really pass in any kind of callback. We can pass in a regular function. We can pass in a custom function object, or we can even pass in a standard function object. All these guys are going to work, and the compiler is going to generate the template instances we need for this to work. Okay, so let's go down and set up a bunch of callbacks that we're going to use. One is going to be a custom function, and the other is going to be a custom functor that we set up. This is going to be a class that overloads the function call operator, and this operator is basically going to be comparing two things. And if what we have on the left is greater, we're going to return a true. Otherwise, we're going to return a false. That's what all these guys are doing, but they are different kinds of function-like entities. The first one is a regular function. The second one is a functor. And down below, we are also going to see that we can use built-in functors to really call our getBest function here. Okay, so we can go down here and use our box container class. We're going to create an object of it, and we're going to add data in. The data is going to be the sky is blue, and we will set up a built-in functor. You see, this is std greater. It is going to be comparing std strings, and we will call this string comparator, and we will be able to use it. For the first time, we will use a built-in functor, which is this little guy here. So we're going to get best. We're going to be getting the best from our code, and we will use our string comparator. This is going to get the best, and this will do lexicographical comparison. We can use our function pointer, and this is going to work. We will instantiate it for std string. We can even use our functor, which is this guy that we are instantiating here, and it is also going to work. You're going to see that we will get the same data, but we have the flexibility to really use any kind of callback we want. Again, we can use a built-in functor, we can use a custom functor, or we can even use a regular function. Everything is going to work. That's going to be your choice what you use in your C++ program. We can pass this through our GCC compiler. The build is going to be good, so we can clear and run rooster, and we will see that we will have the data in our thing. So if we go down here and print this out, we will see the data, and the greater is going to be sky, because we will be doing lexicographical comparison using the less than operator as we have seen here, and this is the default behavior even in built-in functors like std greater that we are using here. So all these guys are going to give us the same result. So it's going to be a matter of choice which one you use in your C++ program. We can grab this separator and use this down below, because we're going to set up a box container of integers and see if the same things we have been doing here also work for other types that we can put in a box container. So we are going to create a box container of integers. We can do that like this. We're going to put in data, and we're going to try and use a built-in functor to compare stuff. We can use our own custom functor, or we can even use our custom greater function for which we are creating an integer instance. And everything here is going to work. We're going to get the best thing in our box container, and that's going to be 72, because this happens to be the greater number in this box container object here. We can try and build our program. We can pass this through GCC. So the build is good as you see here. We can clear and run rooster. And if we go down here, we're going to see that greater is 72 as we have here. This is the greatest thing we have. We also have a lesser printed out here, because this is going to be a built-in functor that we can use to target the smallest element in our container, and you're going to see that this is even going to work. So this is really cool. This is all I had to share in this lecture, showing you that you can use built-in functors or function objects, and most of these guys are going to live in the functional header. If you want, you can head over to your favorite C++ reference and really look at them all. They are going to be available here. So it is a matter of search and finding what you like and using it in your C++ program. We are going to stop here in this lecture. In the next one, I am going to show you that we can actually set up functors that take parameters, and that's going to allow them to store state, a really big advantage on function pointers that we have learned about so far. So go ahead and finish up here and meet me in the next lecture.